Welcome. Today, we're going to get into the math behind building a really strong investment portfolio. And to make it all make sense, I want you to think of it like you're building a championship sports team. You see, it's not just about picking the star players, it's really about how they play together to get that win.
So let me ask you this. When you look at a team, how do you actually judge its potential? Is it really just the average skill of each person on the roster? Or is there something more? Something about how they perform under pressure, their consistency? Well, that's the exact same question we ask with our investments. It's never just about the expected return. It's also about the risk.
Okay, so here's our game plan. We're going to start simple with portfolio return. Then we'll get into what I like to call the secret sauce, covariance. After that, we'll see how to calculate a portfolio's true risk, learn a great strategy for picking the safest option, and then we'll wrap it all up with the key things you'll want to remember for any exam.
First up, let's talk portfolio return. You know, before we can even think about building our team, we have to scout the players, right? We need to figure out how many points each one is expected to score. And in the world of portfolios, that's just the expected return. And the math here, it's actually super straightforward. The expected return of your whole portfolio is just the weighted average of the returns from each individual asset. Think about it in team terms. If your star player takes, say, 60% of the shots, their expected points are going to make up 60% of your team's total score. It's really as simple as that.
All right, now for the really cool part, the secret sauce. In our world, we call it covariance. This is where we stop looking at individual stats and we start looking at team chemistry. I mean, you could have a team of all-stars that looks amazing on paper, but if they just don't play well together, they are not winning any championships. So what is covariance? Well, it's our mathematical way of measuring that team chemistry. It tells us how the returns of two different assets tend to move together. Do they both go up and down at the same time, or does one kind of zig when the other one zags?
And this slide breaks it down perfectly. So on the left, you've got positive covariance. This is when both your players are on fire, having great games at the same time. Their returns move up together. That's awesome when it's happening. But look at the right side. This is negative covariance. Here, one player's having a tough night, but the other one steps up their game to compensate. Now, this is what creates consistency and stability for the whole team, because it's not totally dependent on one person's performance.
Okay, this is a covariance matrix. Now, I know it might look a little intense, but it's just a really organized map of the team chemistry between every single player. It shows you the covariance of asset A with B, A with C, B with C. You get the idea. But check out that diagonal line. That's the covariance of an asset with itself. So what does that mean? Well, here's the crucial point, and you're going to want to remember this one. The covariance of any asset with itself is simply its own variance. And variance is just a way to measure an asset's individual risk or its volatility. Think of it as that player's personal consistency. This is a really key building block for what's coming next. Okay, so now we can see how all these pieces fit together to calculate the true risk of our portfolio. And like we've been saying, the team's overall risk isn't just the average riskiness of its players. No, it's heavily, heavily influenced by that team chemistry, the covariance that we've been talking about. So here's the formula for a two-asset portfolio. You can see the individual risk parts. That's the variance of asset A and the variance of asset B, all weighted. But look at that final piece of the puzzle. That's the covariance, the interaction between them. This shows so clearly that the relationship between your assets is a massive part of the total risk. Now watch what happens when we add a third asset. The formula gets longer, of course, but notice what's growing the fastest. We now have 3 variance terms for each asset, but we have 3 separate covariance terms. As your portfolio gets bigger, the number of these team chemistry terms just explodes, and they quickly become the main driver of your total portfolio risk. Theory is one thing, but let's make this real with an actual example. Here, we're plugging in the numbers, the weights for 3 different assets, let's say stocks, bonds, and international equities, along with their variances and their covariances. And when you run all those numbers through that big formula, you get a portfolio variance of 194.34. That number right there, that's the team's actual combined risk profile. And this brings us to one of the most important takeaways of this entire explainer. It's summed up perfectly here. The lower the covariance terms, the lower the portfolio variance. Finding assets that don't all move in perfect lockstep, that have that good team chemistry, that is the absolute key to building a more stable, less risky portfolio. So we can measure our team's expected score, and we can measure its overall risk.
The big question is, how do we use that info to make the best choice, especially when everything's on the line, like in the championship game?
This is where a concept called shortfall risk comes in, and it's exactly what it sounds like. It's the risk that we fail to meet a critical goal. It's the probability that our portfolio's return drops below some minimum level that we absolutely have to hit. In our sports analogy, this is the risk of not scoring enough points to win the final game. To manage this shortfall risk, we use something called Roy's Safety First Criterion. And it's a really simple 3-step strategy. Step 1, you figure out your minimum acceptable return. That's your threshold. Step 2, you calculate the safety first ratio for each portfolio you're looking at. And then, step 3, you just pick the one with the highest ratio. Simple as that. And here is the formula for that ratio. Let's break it down real quick. On top, you have the portfolio's expected return minus your minimum required return. That's your cushion. Then you divide that cushion by the portfolio's standard deviation, which, by the way, is just the square root of that variance we calculated earlier. So this ratio is literally telling you how much cushion you're getting for every unit of risk you take on. This slide is perfect because it shows you why a higher ratio is better. So we've got 2 portfolios here, A and B. You can see portfolio B has a higher safety first ratio. Now look down at the graphs. See that little shaded area on the left of portfolio B's curve? That tiny area represents the shortfall risk, the chance of failing to meet our goal. Because B has a higher ratio, that failure area is smaller. A bigger ratio always means a smaller chance of failure. It really is that intuitive. Let's just run through one more quick example to lock it in. We have 3 portfolios, and we need a minimum return of 3%. So we calculate the safety first ratio for each one. Portfolio A gives us 0.5, B gives us 0.4, and C gives us 0.44. Well, 0.5 is the highest number, so according to Roy's Safety First Criterion, Portfolio A is our winner. It gives us the best shot at hitting our goal. All right, let's bring it all home and go over the most important points, especially if you're studying for an exam. This is the stuff you absolutely positively need to remember. Okay, first, remember that portfolio return is just a simple weighted average. But the critical insight is that portfolio risk is driven by those covariances, the team chemistry, way more than by individual risk. That means finding assets with lower covariances is your best strategy for lowering overall risk. And finally, when you have a specific goal you absolutely must meet, Roy's Safety First Criterion is the tool you need. And the rule is always the same. Pick the portfolio with the highest safety first ratio. So we started this whole thing with the idea of building a winning team. And we've seen how the math completely backs that up. Success isn't just about individual talent, it's about how all the pieces fit together. So I'll leave you with this final question. Now that you understand the math behind team chemistry, what kind of chemistry will you be looking for in your own portfolio?
我是替纽约